Hello everyone, I'm presenting this video as my final project of course Wireless Communications of Professor Wu of University of Florida. The topic of this project is channel estimation of OFDM systems. I'm trying to make this explanation simple and understandable to comprehend. The agenda of the project is as follows. The first one is the introduction, followed by OFDM merits and demerits, modulation and demodulation, OFDM channel estimation, palette form, and channel estimation method. The first part is introduction. OFDM is one of the ways in which multi-carrier transmission schemes are implemented. In many literature, OFDM is also called discrete multi-tone modulation. OFDM utilized inverse fast Fourier transform and fast demodulation respectively. It is a multi-carrier transmission scheme with the lowest complexity and it is widely used. The second part is OFDM demerits and merits. OFDM has many merits like it can send a lot of data in the narrow band. It can continuously monitor the sudden changes in the communication characteristics on the transmission medium. It can detect the specific carriers in the transmission medium. And it has a strong anti-fading ability and very resistant to narrowband interference because this disturbance only affects a small part of the sub-channels. The method based on IFFT, FFT can be used, and the channel utilization is really high, and OFDM improves the capacity of the system to transmit information, and it can be used to achieve an attractive single frequency network. However, there also exist many demerits of OFDM systems, like it is more sensitive to carrier frequency offset and phase noise than single carrier systems, and a single OFDM system has a high peak-to-average ratio, which results in a decrease in the power efficiency of RF amplifier. The third part of the presentation is modulation and demodulation. The picture shows a simple OFDM generation process. Each OFDM system is the sum of plurality of modulated subcarrier signals, where in the modulation scheme of each subcarrier may select PSK and QAM, and the following equations express the OFDM symbol. This is OFDM symbol, which shows orthogonality of the OFDM. The orthogonality can also be understood from the frequency domain. From the spectrum of each subcarrier signal of OFDM, it can be seen that the spectral value of all the other subchannels is exactly 0 at the maximum of each subcarrier frequency. The next part is the OFDM channel estimation. Channel estimation is the hot spot in the field of communication, which is the basis for correlation detection, demodulation, and equalization. Due to the emergence of OFDM multi-carriers, this provides a new space for the application of channel estimation technology. From the earliest diversity of single-carrier channels estimation to the existing diversity of multi-carrier channel estimation, from the time domain or frequency domain channel estimation to the current time frequency domain to dimensional estimation channel estimation performance continues to increase. In this paper, the palette-based OFDM channel estimation is described in detail, and the comparison and the simulation of the typical estimation methods are given. Then we will introduce the palette form. The palette scheme based on palette symbol channel estimation is determined by two important parameters, the maximum speed and the maximum multipass delay. In order to be able to keep up with the time frequency variations of the transfer function, the palette symbols should be placed sufficiently close, but the palette symbols cannot be too much, which will reduce the data rate. There are three types of palette form. The first one is contact palette form, which are evenly distributed within each OFDM symbol, and it has a higher repetition rate within an OFDM symbol, and there are only some subcarriers contain palette signals, and the estimate of the data information channel response can be gotten by the agency's palette subcarriers, so it is an appropriate option for fast-fitting channels. The second one is a block palette form, in which a palette signal is periodically transmitted within a particular OFDM symbol. This form is particularly suitable for slow-fitting channels, since in a symbol carrier is all flat. The channel interpolations does not need to be carried out in the frequency direction. The third one is the scattered palette form. The palette signals is evenly distributed in both the time and the frequency direction. It can use lesser number of palettes than the first two forms and has good performance. It can check the channel variety better. The next part of the presentation is OFDM channel estimation methods. There are two main methods, channel estimation system methods in time and frequency domain. The picture shows the channel estimation system model in frequency domain. The binary information and inserted palette signals are mapped into QAM signals by encoding. After IDFT, the signals were transformed. The next picture shows the channel estimation system models in time domain. In this manner, the palette signals is periodically inserted in each OFDM symbol. The response of the channel is estimated using the correlation of the received palette signal and the PN sequence stored by the local receiver. There's an improved channel estimation system model in time domain. In this algorithm, an OFDM symbol intervals is divided into L equal long subintervals, and it is assumed that the multipass delay is invariant within an OFDM symbol, and the variations of single amplitude and phase within one subintervals is negligible, and the received signal is divided into two parts, namely long-term fitting and short-term fitting. Finally, we can draw a conclusion of this presentation. The paper first analyzes the basic principles of OFDM as an efficient multi-carrier modulation technology and briefly discusses the latest development, technical advantages, and disadvantages of OFDM system and its applications. In order to facilitate the analysis of channel estimation performance, the general characteristics of wireless mobile channels are also analyzed. Based on the estimation of the palette signal, we must first determine the form of the palettes from three types of palette forms, like comb type, block type, and scattered palette form. In this paper, we discuss the establishment of the intervals of the palette signals in the direction of the time domain and the frequency domain, and analyze the different palette forms. Several different estimation techniques are proposed for different fitting channels, and several methods of channel estimations are proposed. The final part of the presentation is the reference. My presentation is over. Thanks you for your watching. Thank you.